Hello friends, good evening. So today we are going to discuss the data science interview questions. What interviewer might going to ask you questions in an interview in a data science, right? So yeah, let's start it. We will consider first question. So first question is like, what is logistic regression? Just give me a minute. I will increase the font size, then you may be able to see, right? Okay. So we will understand firstly what is the logistic regression, right? So logistic regression, it is the regression technique. Okay, logistic regression, it is a regression techniques that will help you to predict the output in a binary format, right? Logistic regression will predict the outputs in a binary form, right? We will see with one example. For example, one of the candidate who is there for a election, right? So he is going to win election or not, right? This is our logistic regression program, right? The output is in the binary format, yes or no. He is going to win the election or not, right? So what is the logistic regression? Logistic regression means it is giving us the binary output. The outputs of the regression is binary. This, it is the linear relationship between the variable, but the output will be binary, right? Okay. So what is next question is like, what is recommendation engine? Okay. What is the recommendation engine? So the goal of recommendation system is to generate a meaningful recommendation to a user with the basis of his rating, right? To rate the user, to recommend a user a product on the basis of his previous rating, right? For example, we can consider Amazon, right? When we go on Amazon, we will get some different kind of recommendation, right? On what basis? The product we are liking previously, on that basis they are recommending us, right? In that manner, recommendation engine is working. Okay. Okay. Now we will understand firstly the difference between univariate, multivariate, and bivariate between univariate, multivariate, and bivariate analysis. Okay, so these are the analysis techniques: univariate, bivariate, and multivariate. The differentiation is based on the variable, how many variable they are using, right? Univariate analysis look at a one variable, right? In a bivariate analysis, it will look at a two variable, and multivariate analysis, that means it will took more than two variables, right? See, for example, we will plot a scatter plot, right? With the help of two variables. So that is the example of univariate analysis. In a pie chart, we can work on the one variable, right? So that is the example of a univariate analysis, right? So do you understand the difference between univariate and multivariate analysis? Okay, this is the important topic. Okay, this is the descriptive analytics technique, right? and the difference is based on the how many variables they are using, right? On the basis of that, these three different analysis techniques are built, right? Univariate, multivariate, and bivariate. Okay. Now, our fourth question today will be, what is supervised and supervised technique or a machine learning process? They might ask you what is supervised or unsupervised technique, or what is supervised or unsupervised in a machine learning. Okay, we can take it as a machine learning, right? So see, when we have a data, right, we have two types of data. Firstly, in one data, we have labels and another data without labels. What is the label? Label, that means we have output in our data, right? With the help of that output, we can predict our future outcomes, future output, right? With the help of this label, we can predict our future outcomes, right? That is the supervised learning. In the easiest way, we have input and output in our data, right? So that means the supervised learning. And when we have only inputs, we don't have output to predict on the basis, right? That is mean the unsupervised learning, right? So the difference is like in the supervised learning, we have labels, right? That means we have an output column, we have Y and X, right? Dependent column and independent column, we both have. That is the supervised learning. And in an unsupervised learning, we only have an input variable, right? That means we only have a X, right? We don't have Y. We have to predict a Y. That is the unsupervised learning. Okay. What was the types of that supervised and unsupervised learning? Which of the modules that are supervised learning and which of the module that is following unsupervised learning, right? So the firstly, we will see that there are at least 4 to 5 models. Okay, we will see the example. Supervised learning, the models of supervised learning are KNN, Navy bias, SVM, decision tree, random forest, neural network. These are the supervised learning models. Okay, and which is the unsupervised learning models? They are like PCA, SVD, market-based analysis, recommender system. Here we don't have output column, right? We have to predict on the basis of input only. So these are the unsupervised machine learning models, right? Okay. Now the fifth question is like, what is the, okay, agglomerative cluster. Okay, so what is the agglomerative clustering? Agglomerative clustering, it is the common type of hierarchical clustering. Okay, it is the bottom-up approach. Okay, in agglomerative clustering, what happens? It's firstly consider each data point as one cluster, right? It firstly consider each data type as a one cluster, and then it will join that one of the data point, every data point, on the basis of similarity until and unless one cluster will form, right? So what is the agglomerative clustering? This is the type of hierarchical clustering, right? In that, each of the data point firstly considered as a one cluster, right? Means if we have 50 data points, Then in agglomerative clustering, we will consider that as a 50 clusters. Okay. And on the basis of that 50 cluster, on the basis of similarities, we will join that data points until and unless only one cluster will form. Right? That is the agglomerative cluster. Okay. Now we will see then next question is like, what is divisive clustering? Right? So yeah, what is the divisive clustering? Divisive clustering is exactly opposite to agglomerative clustering. Okay, in a divisive clustering, we can consider a data set, the 50 units of data set as one cluster, and we can divide that data, means we can divide the data on the basis of dissimilarities, right? On the basis of dissimilarities, we can divide, we can separate that data from a cluster until and unless we form multiple clusters, like each cluster for each data point. Means agglomerative clustering and divisive clustering are exactly opposite. Okay. And how we are considering, how we are calculating similarities and dissimilarities, that would be a next question, right? If you are calculating similarity between a cluster and dissimilarity between a cluster, what is the method? Okay, how to calculate similarity between clusters, right? That would be my next question. Okay, so okay, so on the basis, yeah, we will calculate similarity between a clusters on the basis of Euclidean distance. Okay, it will calculate the Euclidean distance between each data point. Okay, and it will see how much the similarity in between those clusters. That means the difference from one cluster to another cluster, distance between one data point to another data point, right? On the basis of that, it will going to join, right? Means first data point and then second data point. So the what was the formula for that? Like, in a square root, x2 minus x1 plus y2 minus y1 square. Okay. So we will use the Euclidean distance to calculate a similarity between two clusters, right? How to calculating the distance, how to calculating the how to combining the cluster with the help of a Euclidean distance, right? And the formula for that is square root of x2 minus x1 square plus y2 minus y1 square. This is the formula, okay, to calculate Euclidean distance. Okay, there is one another way as well to calculate the similarity between a cluster. The way is like Manhattan distance, right? The difference is like just only modulus of the formula difference is like the modulus of x2 minus x1 plus modulus of y2 minus y1 square. Okay, this is the two way to calculate the distance between two clusters. Okay, Euclidean and Manhattan. Okay, now next question is like, is normal normalization data required before applying clustering. Is normalization required before applying a clustering technique? Okay, so yes, normalization required. Why? Because normalization is used to eliminate redundant data, right? It will give us the clean data, right? That means when we are going to form our cluster, it will give us the good quality clusters. When we apply normalization on our data, it will eliminate redundant data and it will give us the clean data, right? After cleaning the data, we can form much more better cluster, right? And we can get a better accuracy. So yes, we have to normalize our data before applying a clustering technique. Okay, now next question is like, so what is the range of variables after normalize? Okay, what is the range of variable after we apply normalization? Normalization on that variables. The range is varies between 0 to 1. Okay, the range is vary between 0 to 1. We can consider this question as like, what is the range of normal? Okay, what we can consider next question as like, what are scaling techniques? What are the scaling techniques? There are two scaling techniques. Okay, one is standardization and another one is a normalization, right? In the standardization, the variables will convert in a range from 0 to 1. Okay, and in a wait, sorry, I think I just miscommunicate. Okay, in a normalization, the variable may convert in between 0 to 1. Okay, and in a standardization, the variable may convert from minus 3.14 to plus 3.14 range. Okay, these are two standardization, two scaling techniques. Okay, now the next one is like 10th one. Tenth question is like, what are linkages in hierarchical clustering? What are linkages in hierarchical So question is like, what are linkages in a hierarchical clustering. Linkages is a criteria based on which distance between two clusters we are going to compute to calculate the similarity, right? Which distance we are going to compute. Distance between a two clusters we are going to compute, right? Which of the distance we are going to calculate. There are different linkage techniques: single linkage, complete linkage, average linkage, right? These are the linkage techniques. Okay, single linkage means it will just consider nearest data point from two cluster to calculate the distance, right? Nearest data point from a cluster A to cluster B, right? Complete linkage means it will consider the longest distance from a cluster A to cluster B. Longest distance point from a cluster A to cluster B, right? And average distance means it will just take average of each data point from one cluster to the another cluster. Okay, average of cluster A data points to the average of cluster B data point. Okay. Now, the question is like, we know now how to decide what is the clustering, what is the linkage in hierarchical clustering. The next question is like, how to decide the numbers of clusters in hierarchical clustering. Okay, this is one question. This is another question. How to decide a number of clusters in a hierarchical clustering? Okay, in a cluster, in hierarchical clustering, we have a dendrogram. We have a dendrogram to decide how many numbers of cluster we want. It is a tree-like structure. It is dendrogram is just like a tree-like structure. It is one of the graph. With the help of that graph, we can decide how many numbers of cluster we want. We have to see longest horizontal line on a dendrogram that is not cutting. Okay, longest horizontal line, and after cutting that line, how many cluster are formed, right? This is the one way to decide a cluster, number of cluster in a hierarchical cluster. Okay. So how to decide a cluster? There we have a dendrogram in hierarchical clustering. In a dendrogram, it is a tree-like structure. In a dendrogram, we have to see a longest horizontal line that is not, when we are cutting that line, how many numbers of cluster are forming, this many number of clusters we have to choose. Okay. Okay. Now we can go with the next question is like, what is the join probability? So what is the join probability? Join probability, that means the two events, the probability of two events is occurring at the same time. Okay, the probability of two events occurring at the same time. For example, we want to predict the mail is ham or spam. But the condition is like, if there we have a word in a mail lottery, then it have to predict as a spam, right? That means we are concentrating on two events, right? The probability of two events are occurring at the same time, right? Means if the word is coming lottery in the mail, then it have to predict as a, then it is going to predict as a spam, right? This is the example of a joint probability. What is happening here? The probability of two events is occurring at the same time, right? This is the joint probability. Now, next is like what are the tuning parameters of SVM? What are the tuning parameters of SVM? Okay. Firstly, SVM means the support vector machine. Okay. The tuning parameter of that is like regularization, kernel technique, gamma, and margin. These are the tuning parameters for a SVM. Okay. Firstly, then the question is arriving like, what is the kernel technique? Okay, what is the kernel in SVM? We can take it as, or explain the kernel in a SVM, right? Kernel is a technique that is nothing but it is transforming low dimension data to high dimension data. With the help of that, we can divide our data with the help of hyperparameter. Means in a easy way, we can, with the help of kernel, we can convert our non-separable data to a separable data. Okay, this is the way of a kernel technique. See, when we have a data that are not easy to divide with the help of hyperplane, okay, so we will just convert that data to 3D data. For example, we have 2D data, we can convert it into the 3D data in such a manner that we are able to divide our data with the help of a hyperplane, right? This is the work. This is the, in this way kernel techniques are using. This is the way kernel techniques are working, right? It is just converting our non-separable data to a separable form. Okay, this is the kernel technique in a SVM. It's just applying transformation on our input data, right, to convert it into the separable form. Okay. Now, question is like, what is regularization in SVM? What is a regularization in a SVM? The value of regularization tell to the training model how much we can avoid misclassifying each training observation. Okay. Value of regularization parameter, whatever value we are going to choose for regularization, it will just going to avoid misclassification of our observation, right? Means if we choose a regularization value too high, it will consider a nearest point, okay, to apply hyperplane there, right? And if we consider our regularization parameter too low, so it will give us the largest margin. Okay, they are giving us some misclassification, but there is no issue, right? Because we want margin as much as possible, right? If we choose a higher value of regularization, it will just give our hyperplane, convert our hyperplane to a curve form, right? So the what is the regularization? Then the regularization is the parameter. It was giving us, or it was telling us how much we can avoid misclassification in our observation, in our data. Okay. Next question, like, what is decision tree? Okay. So the decision tree is a supervised machine learning algorithm. It is used for both classification and a regression analysis. Decision tree is a supervised learning technique in a machine learning. Okay, it is used for both classification and a regression problem. Okay, it is a tree like a structure in which we have internal node, branches, and leaf node. Okay, internal node means, sorry, root node, that means when our decision tree are started. Leaf node, that means the outcomes, and branches means the decision rules. Okay, this is the decision tree. So decision tree means it's a supervised learning technique, and it is a tree like a structure where we have root node, branches, and leaf node. Okay, now question is like, what is pruning and decision in a decision tree? We have pruning. Okay, pruning we are used to overcome with the overfitting issue. Okay, in a pruning we will just cutting out the nodes that are not giving us the much information. Okay, with the help of that we can avoid our overfitting. Okay, the two types of pruning, like pre-pruning and post-pruning. Pre-pruning, that means we don't want this much leaves, we don't want this much rules, so we already giving them the criteria, the number, this much we want the nodes. This means the pre-pruning. Okay, post-pruning means once the whole decision tree form, we cutting out the nodes. That means the post-pruning. Okay, so pruning is a technique, is helping us to overcome from a overfitting of a model, decision tree model. Okay, in that we are just cutting out the nodes. Okay, cutting out the nodes. That is the pruning technique. Next question is, what is the advantages of pruning? Okay. Advantages of prunings is like it is reducing the complexity of model, right? If the complexity of model is reducing, that means it is overcoming the issue of overfitting, right? It's solving the issue of overfitting. Now we can go with the data types. The question is like, what are the data types in a data? What are the data types are there for our data? Okay, so firstly, briefly, we have continuous data, means numeric data. Sorry, firstly, we have numeric data and categorical data. Okay, numeric means we have numbers, categorical means we have the words like male, female. Okay, the categories format. Okay, in a numeric data, we subdivide our data types in continuous and discrete. Okay, so continuous data types, that means we have continuous values like 1, 1.5, 2, 2.5, 3, 3.5, right? This is the continuous. And the discrete means 1, 5, 7, 6, 8, like this, right? Like, for example, time. Time is a continuous data, right? We can tell them like 2:30, 1:50, 1:20, 6:30 p.m. This is the continuous data, okay? And if we see the laptops, like, okay, number of laptops, 1 laptop, 2 laptop, that is the discrete data. We can't say we have 2.5 laptop, right? We say 1 laptop, 2 laptop, 3 laptop. That means the discrete data, okay? And in a categorical data, see, continuous and discrete, this is the data types of numeric data, okay? And again, we have categorical data. In that also, we have 2 data types, right? Nominal and ordinal, okay? So nominal data means the labels, okay? Labels, that mean, for example, male, female, yes, no, like Coca-Cola, Pepsi, some brand names. This is the nominal data, okay? But ordinal data, that means they have some order in a data, natural order in a data. We can think with the help of our education system, right? For example, firstly, nursery, then high school, then the college, then our graduation, post graduation, PhD. We have some kind of a order there, right? That means the ordered data, okay? So how many types we have? 2 more main types, numeric and categorical. In numeric, we have continuous and discrete, okay? And in a categorical data, we have nominal data and ordinal data, right? Okay. Now, there are some sub data types as well. So they might ask you, the next question is like, how is, how is interval data type different from ratio? How is internal data type different from a ratio? This both are a numeric data types, interval and a ratio, but there is differences like in a ratio we have absolute zero. Okay. Sorry, in interval data types we have absolute zero. Okay, that means we can consider with example. See, if we consider temperature, okay, temperature of yeah, temperature of Hyderabad, today's temperature of Hyderabad, okay, 34 degree, 35 degree, but in other states it will go till zero, right? Or in the other country it will be 0 degrees Celsius, right? But we have some values of that 0 degrees Celsius. That means there is too cold, right? There is too cold. That means we have some value to zero, right? We have some value to zero. Okay, this means the interval data type. Okay, and the ratio data type means there is no value for zero. Like, can we consider the height of person 0 to 6 feet? Okay, so 0 means nothing, right? 6 feet means, yeah, he is a 6 feet tall, right? So when we have interval data type, we have some value for zero. This means the interval data types. Like temperature we have, for example, yeah, in temperature we can consider 0 means too cold. Means 0 is having some kind of value there. That means the interval data type. Now the next most important question, what is normal distribution? Okay, normal distribution is the Bayes. This is a sorry. Normal distribution is also called as a Gaussian distribution. Normal distribution, that means the data have to form, data have to be in a form of a Bayes curve. Okay, it is shown in the form of a Bayes curve, right? So the mean of that data should be 0 and standard deviation is 1. Okay, if we calculate probability of any single point for that data, that should be 1. Okay, so normal distribution means it is called as a Gaussian distribution and the data have to follow a bell curve form, right? And in that, the properties of normal distribution like mean should be 0 and standard deviation should be 1. Okay. Now, what is the standard normal distribution there? Okay, so standard normal distribution, that means when we apply Z transformation on our normal distribution data, normal distribution, that could be a standard normal distribution. Okay, the range of normal distribution is like minus infinity to plus infinity, but after converting it to standard normal distribution through a Z transformation, the range from minus 3.14 to plus 3.14. The advantage of standard distribution with like we can calculate area belong to each standard deviation, how much it will be. Okay, mathematically in a normal distribution it will not possible. With the standard normal distribution, yes, it is possible. The next question is like, what is differential statistics? Okay, what is the inferential statistic? See, we have a population data. We have a data in huge data. That means our population of big data. Okay, but sometimes we can't calculate mean for the data. Okay, so in inferential statistic, what we are doing, what we done, we take sample of that data, sample from that population data. Okay, we do some calculation on that, and with the help of that calculation we can make statement about the population data. For example, if we take example of the elections, okay, they are not going to take each one's what means they are not going to ask each of the candidate like to whom you are going to vote, to whom you are going to vote, right? They are just choose one of the field, one of the area, they goes there and they ask, they take their suggestion, right? And they ask which you think are going to win, right? So as per that they are just predicting, okay, this many sample people are telling this is the person are going to win, so they are just considering, okay, this is the person are actually going to win, right? That means we have population, India is a population. Okay, from there it will just take a sorry, Telangana is a India is the population, and they, in that they just select the Telangana state and they are going to do a survey and ask the people which of the candidate you are thinking to win in a future, yeah, in a future election. Okay, on the basis of that they can assume, yeah, in a future this is the candidate, he's going to win, right? That means they are making a statement about population on the basis of a sample data. This is the inferential statistic. Means we are able to make a statement about the population on the basis of a sample data, right? This is the inferential statistic. Now the next one is what is central limit what is central limit theorem? Okay. In a central limit theorem, we can see if we plot our population data, it will might not follow a normal distribution. Okay, central limit theorem is telling us. Okay, so if we plot our population data, it will not follow a normal distribution. But if we take sample from those data and calculate mean of that, and then we plot the mean of that sample, it will going to follow a normal distribution. Okay. CLD states that if you have population mean like mu and standard deviation and take sufficiently larger random sample size should be like 30, okay, from the population with replacement, then the distribution of sample mean will be normally distributed. Okay, that means when we have a population data, we can take multiple samples from that data, okay, with replacement, okay, and then we calculate mean of that each sample, and if we plot a mean of each sample, it should be normally distributed. This is the sample limit theorem is telling us. Our today's last question will like, what are sampling techniques? Okay, so we have multiple sampling techniques like simple random sampling, stratified sampling, cluster sampling. Okay, these are some of the sampling techniques. Okay, simple random sampling means just taking a samples random. Stratified sampling, that means when we have, for example, we have a data of 100 of females and we have 1,000 data points, and there in that we have a 100 females and 900 males. Okay, so with the help of stratified sampling, we can choose 30% of a male data set, male observation, and 30% of a female observation, right? This is the stratified sampling technique, right? Means if we are having this kind of data and we take a stratified sampling technique, we can avoid a imbalance. See, if we have imbalanced data like 100 of male and 500 of female, right? So we if we take a random sampling, it will just might be chances to take only the males data set, right? Because that are huge. But if we take a stratified sampling and we decide like we want a 20% of sample, so it will just going to take a 20% of male samples, 20% of male sampling, and 20% of data for a female data sample. Okay, so I think that's it for today. Tomorrow we are going to continue our topic. Okay, the interview questions. Thank you so much.